How's it going, everyone? Cup of Science Joe here. Have you ever noticed that during a solar eclipse, or even when viewing an image of one, that there is a faintly glowing area that becomes visible around the sun, usually when you're in a total solar eclipse? I used to think this was rays of light simply not fully being blocked, but as it turns out, it is actually the outermost portion of the sun's atmosphere known as the corona. Normally, the corona is hidden by the bright light of the sun, which is why either an eclipse or special instruments are required to see it. Now, the sun and its corona are behaving in a way that myself, and I'm sure probably others, did not initially expect. You see, its surface chills out at around 10,000 degrees Fahrenheit, although that is very hot. While just 1,000 or so, 1,500 miles up, once you start entering into part of the sun's corona, the temperature can spike up to 2 million degrees. This is like walking away from a campfire, but it starts getting hotter the farther away you move. While this has been a topic of study since the 1800s, we don't currently know for sure how or why this happens. It is currently known as the coronal heating problem. There are a few compelling theories on just what might be part or most of what's causing the coronal heating problem. The first one I would like to touch on is nanoflares. Nanoflares are tiny explosions, kind of like small solar flares, that can reach upwards of 18 million degrees Fahrenheit. This plasma is accelerated out from the explosions and seem to impart that heat across the corona. It probably kind of gets spread out and dispersed. The Eunice mission showed us that this hot material was even in regions that were visibly quiet, a sign that it was not placed there by a more high-energy event such as a solar flare. Next, let's turn our attention towards the sun's powerful magnetic field. Here we are gaining two potential sources of heating. The first is known as wave heating. This posits that mechanical energy is being moved by magnetic waves into the corona. This energy is then deposited there as heat, and this can happen if the waves are dampened at a low enough height. The second is magnetic reconnection, a chaotic process in which oppositely directed magnetic field lines break and then reconnect inside the plasma of the corona, which we think has the effect of converting that magnetic energy into thermal energy, thus imparting it into the corona. Now, how are we studying something that is so difficult to see, and given how hot it is, also so difficult to reach? Outside of solar eclipses, we have access to an instrument called a coronagraph. What this does is basically imitates a total solar eclipse by placing a piece of the instrument directly in the spot of the sun, like in view of the camera, or if you're a visual observer, your eye, and this effectively blots it out. This allows a visual observer to view any faintly lit things around it, such as the corona, or if a camera is attached, photos can then be taken. The coronagraph has other uses as well. A new class of them came about recently that have aided us in the discovery of exoplanets. Little fun fact for you there. We also have probes that are assisting us in studying the corona. In 2021, the Parker Solar Probe flew through the upper portion of the sun's atmosphere. This is going to give us an idea how big that atmosphere is, by the way, because at the closest approach the Parker Solar Probe will make, the spacecraft will come within 3.9 million miles of the sun. and that is still part of its atmosphere. NASA also has an upcoming mission called Punch. I may cover this a little bit more in a future video. Punch aims to launch 4 suitcase-sized satellites, which will work in tandem with each other to produce images of not only the corona, but the entire inner solar system. I am certain that there is much we can learn and a lot of data we can gather from this mission should it be successful. I hope you've learned something, and I implore you to step outside tonight and look towards the stars.